Hello, good evening everyone. Welcome to BYJU'S exam prep. Yes, so the video and audio are absolutely fine. So I hope that all of you are able to listen me and I am visible to all of you also. ठीक है, तो जल्दी से सभी लोग इस सेशन को शेयर कर देंगे बिकॉज जो सेशन है उसमें आपका ईएमएफटी के क्वेश्चंस हम लोग सॉल्व करने वाले हैं. ठीक है, तो ईएमएफटी के क्वेश्चंस हम लोग यहाँ पे डील करेंगे. So before starting the session, let me introduce myself. Yes, so I think some of the students have joined. Yes, Aneem World, good evening. So let me introduce myself. So this is Sakit Verma and I have done MTech from IIT Guwahati and I cracked the different PSU exams and I have mentored more than lakhs of students and having more than 13-year experience in the field of GATE and ESC only. Okay, so this is my Telegram group, and if you want the solution of any questions, whatever we are going to solve today, and suppose if you are not able to understand and if you need the solution, then you can ask me in this PDF for the PDF in this particular Telegram group. And also, it is important to connect with me and also get the important update regarding all the different series that I am going to launch in this month. I'm going to launch the multi-subject series. I'm going to launch the Master Blaster series for communication for EMFT. So there are multiple series that I am going to launch in this session. So to get all updated for all the batches and all the series, you should be able to join this Telegram group, and the link is given in the description. And also in the app, BYJU'S Exam Prep app, I am going to launch the mock test for the ISRO, mock test for the GATE. So these are also coming line up in this particular month. So you should join. Yes, Rahul, application. Yeah, actually, I'm comfortable working with the BYJU'S, so no need to work for self. Actually, because I have a certain lack of certain subjects like core subjects of EDC, analog electronics, and some common subjects, network digital. So that for that I again have to start preparation and go through that, and then I have to teach you. So because of that, and also I'm very much comfortable working with BYJU'S, and this is good platform and excellent team we have. So I don't want to move anywhere, and that's why I'm not trying to open up my own application, right? So please answer this question. Answer this question. I'm giving you 2 minutes time. Yes, Rishit Ghosh. ठीक है राहुल, आपको आई होप कि आपका आंसर मिल गया हो और सभी लोग आंसर करते जाएंगे फटाफट, क्योंकि यहाँ पे हम लोग सॉल्व करने वाले हैं अप्रोक्सीमेटली 25 क्वेश्चंस. अप्रोक्सीमेटली 25 क्वेश्चन. यस. वीपी राहुल, ईएमएफटी का डबल ई का कोड सेपरेटली नहीं मिल आपको, मतलब कॉलिंग नंबर होगा डिस्क्रिप्शन में, कॉलिंग नंबर दिया होगा, आप उसमें से जाके देख सकते हैं. एंड बायजूस एग्जाम prep ऐप अगर आपके पास है तो आप याद रखो कि ऐप में 20 लेक्चर्स फ्री ऑफ कॉस्ट अवेलेबल होता है. तो अगर आप सिर्फ इलेक्ट्रिकल का ईएमएफटी करना चाहते हो तो आप बिल्कुल रिकॉर्डेड लेक्चर देख सकते हो ऐप में फ्री ऑफ कॉस्ट, क्योंकि 20 लेक्चर्स आपका फ्री रहता है और 20 लेक्चर्स में आपका ईएमएफटी इलेक्ट्रिकल का कवर हो जाएगा. तो आपको जरूरत नहीं पड़ेगी पेड कोर्स की. और अगर उसके बाद आपको बाकी सब्जेक्ट्स का भी एक्सीलेंट कंटेंट चाहिए तो फिर आप उसके बाद प्लान कर सकते हो. ठीक है, तो आपको एक मैं ऑप्शन दे रहा हूँ जिसके थ्रू आप फ्री ऑफ कॉस्ट 20 लेक्चर्स के थ्रू, क्योंकि 20 लेक्चर्स फ्री ऑफ कॉस्ट रहता है तो आप सिर्फ जिस सब्जेक्ट को टारगेट कर रहे हो उसी सब्जेक्ट को लर्न करो. अगर आप मान लो 5 लेक्चर अगर ईएमएफटी का देखते हो, 5 किसी और सब्जेक्ट का, 5 किसी और का, तो फिर आपका कोई भी पर्टिकुलर टॉपिक कवर नहीं हो पाएगा. तो यार 21 स्टूडेंट्स लाइव दिख रहे हैं मुझे, बट आंसर मुझे अभी तक 2 ही मिला है. तो गाइज कम ऑन, आंसर द क्वेश्चन. द मैक्सिमम रेट ऑफ चेंज ऑफ फंक्शन विच इज इन इंक्रीजिंग डायरेक्शन, विच इज इन इंक्रीजिंग डायरेक्शन. Come on, quickly answer this question. 4 seconds left now. Kanari Rajesh is saying A. So the right answer for this question is B. See, the gradient of any scalar function gives you the rate of change of rate of change per unit distance, right? अगर आप देखोगे तो अगर मान लो सपोज करो कि मैं किसी स्केलर का ग्रेडियंट लेता हूँ, सपोज ग्रेडियंट ऑफ v. So first thing, how to calculate? So to calculate the gradient in suppose Cartesian coordinates अगर बस मैं लिखूं तो डेल्टा v इंटू डेल्टा एक्स ए एक्स कैप होता है एंड डेल्टा v अपॉन डेल्टा वाई ए वाई कैप होता है एंड डेल्टा v अपॉन डेल्टा जेड ए जेड कैप होता है. तो यहाँ से आप देख रहे हो कि ये जो dx dy dz है ये आपको क्या शो कर रहे हैं? रेट ऑफ चेंज of the quantity, okay, of function per unit distance, per unit distance. ओके, सो ये चीज आपको पता होना चाहिए कि पर यूनिट डिस्टेंस शो कर रहा है पहला. और दूसरा ये है कि इसका जो रिजल्ट है, रिजल्ट ऑफ ग्रेडियंट, ओके, रिजल्ट ऑफ ग्रेडियंट हमेशा एक वेक्टर क्वांटिटी होता है, इज वेक्टर. ओके, थर्ड आप ये देखो कि जिस डायरेक्शन में ये शो करेगा, जैसे कि क्योंकि वेक्टर क्वांटिटी है तो इसका कोई डायरेक्शन होगा, तो जो डायरेक्शन है दैट विल बी ऑलवेज द इन द डायरेक्शन ऑफ मैक्सिमम रेट ऑफ चेंज. तो यहाँ पे जो मैक्सिमम वर्ड यूज किया है, मैक्सिमम रेट ऑफ चेंज के डायरेक्शन में इसका ग्रेडियंट ऑफ फंक्शन रिप्रेजेंट होगा. ठीक है, ग्रेडियंट ऑफ फंक्शन रिप्रेजेंट होगा. नेक्स्ट पे आते हैं, चलो. Quickly like the session also. Immediately, all of you should like the session and also share the session. Shweta and Rishit both are saying D. Okay, so time up. So the right answer for this question is option number D, yes. So curl of, because this is saying the electrostatic field. So static field, so in this static field the curl of E is 0, or we can also say that the work done, total work done inside a closed loop is also 0. So from this relation we got this curl of E 0. This is the Maxwell equation. It is the negative gradient of scalar potential. So electric field is also the negative gradient of the potential. That's also correct. The electric field is a vector quantity and this V is a scalar quantity. So we will at least say that this is E is equal to minus of gradient. E is conservative because the curl of E is zero. Since the curl of E is zero, it is conservative because the total work done inside the closed loop in the presence of electric field is also zero. So all these three statements are correct. Yes. So Nasima, have you got this? Option C you were saying, but actually all the three are correct. Now answer this one. Actually, I'm giving time to listen to understand all the options carefully because all the other students are also important. So those who are able to answer, wait for the 2 minutes. Which of the following is zero as applied to the electric field? Just now we have solved this one. Just now. Yes. So one answer I have got Rishit, Atik, Ashik. So Ashik. Yes. Nasima also got yes. So three answers I have got. Yes. Where is Shweta? Shweta and Rajesh. Anim World. All of you answer this question quickly. 10 seconds left. So from the vector identity, we know that yes. So from vector identity, we know that there are few points like divergence of curl is zero, curl of gradient is zero, right? So this is divergence of curl. DC zero means divergence of curl of a vector is zero, and curl of gradient, that is curl of gradient is zero. Divergence of curl is zero and curl of gradient is zero. Right? So here there is an option because it is MSQ question, so you can be check also for this say curl of gradient also, right? So the answer is option C. Now answer this. Which of the following cases the divergence of the electric field is zero? The divergence of electric field is zero. So three answers I have got. The right answer, in which of the following cases the divergence of electric field is zero? So three different answers I've got, and Ishik, if you can answer, Nasimha has given the answer, Shweta has given the answer, Rajesh, Anim World, Rahul, Pavitra. See, here you can see that in this particular case, the net field, the electric field is coming in, the number of electric field coming in and number of electric field is going out are same. So this is the case where the divergence of electric field is zero. Here the net field is going outward. So here we will say the divergence of E is not equal to zero and mainly it is positive. Okay, here mainly it is positive and here it is all inside. So we will say that when the electric field uniform through the open tube, so it is going inside and outside, both are same. So we will say that the divergence will be zero when the net electric field passing through the tube and is same inside and outside. The net divergence here is same. We have already discussed that the field passing through any cross section area should be same. The divergence is what? Divergence is nothing but a, if you write, divergence is a measure of, is a measure of how much a field diverges about any point. Okay, diverges about any point. Now answer this one. One by two, Rishit is saying one by two. He took around 1 minute to solve this question. And what about others? Yes, curl is non-conservative, zero point 0.5. Two answers I have got, both are zero point 0.5. So here we have to solve this, and because it is curl, so let's calculate the curl. And how do we calculate it? For the scalar quantity, this is curl of m I am calculating. So this is ax and ay and az, z cos xz. So this is z cos xz plus y, and the y is 2kx, and the z is x cos xz. So del upon del x, del upon del y, and del upon del z. So this is the value of the curve, because the vector m is given as conservative. Okay, it is given as conservative. So if a vector is conservative, then its curl is 0. Okay, so in this way we will solve it. Curl of m equal to ax cap in bracket del upon del y. So del upon del y of x cos xz minus del upon del z of 2kx, and minus of ay, and del upon del x of x cos xz minus del upon del z of z cos xz plus y, and then az cap del upon del x of 2kx minus del upon del y of the remaining term. I'm not writing that. So x cos xz, it is 0 with respect to x, because when we differentiate it with respect to y, it is 0. When we differentiate with respect to z, it is 0. Now minus of ay. When we differentiate with respect to x, so this is minus xz sin xz plus cos xz. Okay, and this is minus, and let's keep it in bracket. So it is again minus xz sin xz and then cos xz. This is the component of ay. Now component of az. Component of az is 2k minus 1, and this is all equal to 0. So minus xz sin xz minus minus plus xz sin xz, this will cancel. Cos xz and minus cos xz, this will also get cancelled. So we will get only 0 is equal to az 2k minus 1. So for this particular vector, curl of m should be 0. It can be 0 only and only if the 2k minus 1 will be 0. So k is equal to 1 by 2. So zero point 0.5 is the right answer. Yes, Anand, zero point 0.5 is the right answer. Yes, electrostatic and magnetostatic is a part of GATE syllabus, whether you are from electronics or electrical. It is definitely for electrical and instrumentation, but for electronics also there is some confusion for the students that whether this is on in the syllabus or not. But mark my word here that they can ask the question from this particular also topic also. So don't miss this topic. Just go through it once. This is not that tough, and you can score if they ask. Even if they not ask, then also it is beneficial for you when you try to understand it. Suppose you are doing masters, then you need some basic understanding of the electrostatic magnetostatic. Suppose you are doing in the RF and microwave field, so it is important for other exam as well, like BARC, ISRO. So that's why you should study this particular part of the electromagnetic also, whether it is mentioned on in the syllabus or not. And even if it is not mentioned in the direct form, but they have asked the question from the electrostatic and magnetostatic. Okay, so minus 2 minus 2 minus 2, I'm getting minus 2. Okay, good. So well, this is easy also, but still that's good that you know what the meaning of this. Yes, divergence of A is 0 if the vector is solenoid. If any vector is solenoid, then if a vector is solenoid, then the divergence of A is equal to 0. So we will calculate the divergence. So this is del upon del x of x component, which is x plus 4z, and del upon del y of y component, that is 2x minus 3y, and del upon del z of z component, that is 4x plus 3y minus cz equal to 0. So when you differentiate it with respect to x, you will get 1. When you differentiate with respect to y, you will get minus 3. And when you differentiate with respect to z, you will get minus c. So c equal to minus 2. Yes, c equal to minus 2. Now answer this. Oh, sorry, this for this timer. This timer was not activated. The gradient of y is equal to x square minus 6x plus 4x plus 6 is same as the gradient at a and b. Then the value of a and b. Anyone? Anyone who got the answer? No? क्वेश्चन नहीं दिख रहा है. क्वेश्चन तो सेम है, यही तो है. और कुछ तो नहीं. टाइम बार के पास तो कुछ है ही नहीं. C, C, you guys are getting C. Okay. So mark this one. Now answer this. I will tell you the correct answer. So because all of you are getting C, so we'll let you know whether this is correct or not. Now answer this. Last 40 seconds. A. A charge Q2 is located in a vacuum at point P2. The force Q2 due to the charge Q1. So due to the charge Q1, this is our final point. Okay, this is my final point, and this is my initial point, right? So now the charge Q2 is located in a vacuum due to force due to Q2, force on Q2 due to Q1. So we want to calculate the force, and by the Coulomb's law we know that this is K Q1 Q2 divided by R cube and vector R. Vector R is the final point minus initial point. So 1 upon 4 pi epsilon naught you can write, or because it is given in the form of 1.8 this is 1 upon 4 pi into epsilon naught. So this is 8.854 into 10 to the power minus 12. 1.4 epsilon naught. Q1 is 8.854 into 10 to the power minus 9 into 4 pi into 10 to the power minus 3. So this is all, and multiplied with, okay, let me write here the multiplication part I am writing over here. So R2 minus R1. So final minus initial 2 minus 2 0. So 2 minus 2 AX and 3 minus 2 AY and 1 minus 1 0. So it is again 0. So all will get cancelled, and we will get AY only. So how many of you got A? Yes, answer is A for Agra. Yes, answer is A for Agra. Yes, the right answer is A. Now answer this. Coulomb's law for the force between the electric charges most closely resembles with. Yes, so most of you have got the right answer only. Yes, so the right answer is option D. Newton's law of gravity, correct? Now answer this. ग्रेडियंट अचानक था, बता रहा हूँ ग्रेडियंट वाले का आंसर अपन लास्ट में करते हैं। बस सब लोग सही आंसर दे दिए थे उसका, इसलिए मैं आगे बढ़ गया था। A charge q is divided between the 2 point charges. What should be the value of this charge on the object so that the force between them is maximum? Okay, so most of you have got the answer also. That's good. The force is Q1 Q2 upon R square, or you can write K Q1 Q2 upon R square. The charge is same, so one is suppose Q, then another will be Q minus Q divided by R square. Okay, so if I differentiate it, then it is K. If I am differentiating with respect to capital Q, so it is Q minus 2Q divided by R square equal to 0. So from here this Q minus 2Q equal to 0. So this capital Q is Q upon 2. Answer is the, you can change the variable, no? Interchange the variable. A charge Q is divided. So the actually I have taken the small charge. So if you will write in the, this can be written as in the small q form. So if it is a small q, then you get the answer in the terms of q vectors. Okay, next. A positive charge of 2 coulomb is located at 003 and a negative charge is coulomb at 00 minus 3 and electric field intensity at 400. So we are getting answer as B and A. Negative Z and negative X. Okay. Negative Z. So suppose we have a charge on both are substituted in the Z plane. Here with the Z axis. So this is suppose Z and we have X over here. So one is at 003 and another is at -3 and we want to calculate 400. Okay. Then what will be this value? This is because 003, this is 00 minus 3. The force is given by K Q1 Q2 R divided by R cube. So K into Q square because the charge is that located at electric field intensity, na? Okay. So it is electric field, not force. So let's write K K Q, okay, K Q vector R divided by R cube. Okay, so from here now this K because of the first one, this is electric field because of the first one I am writing. So K Q R square vector, our final point is this. So this is 4AX and initial point is 003. So minus 3 is Z divided by R cube. I'm not calculating this because I think it will not be required. This is K, Q, vector R here also, R cube. This formula we will apply. This is R1, this is R2. So K, Q, final point is our 400. So this is 4AX only. But here it is plus 3AZ divided by R cube. So when we will solve it because electric field follows the superposition law. So E1 plus E2 when we solve, we will get KQ upon R cube into 8AX and rest of this Z component will be 0. So it means it is in the positive X direction. Okay, so this is option B, option C, positive X direction. Positive X direction. Which option B you are saying, negative Z or positive X? Actually, there are repetition in the options, but negative Z option B he is saying. So have you got the answer? That it answer will be the 8AX. That means in the X direction will be positive. है ना वो भी positive होगा. Okay, wait. A positive charge and a negative charge. Okay, right. You are saying right. This is negative charge. So this is negative charge. So minus 4Q and this will be plus. So it will be minus. So minus will become plus. So yes, it is 6AZ with negative sign. So answer is negative Z. Correct. Negative Z direction. Okay, one is positive charge, another is negative charge. I forgot to take that negative charge. I thought that both are same magnitude. Yes, negative sign. Negative sign is there. Yes, I missed that. Correct. Electrostatic force of repulsion. Two alpha particle of charges is separated by this value. Okay, that is the direct question. See, okay. So this force we want to calculate, and because it is not in the form of vector, so K Q1 Q2 upon R square. So we want to calculate the magnitude only. So 9 into 10 to the power 9 into charge. So this is 4 into 10 to the power minus 19 whole square upon R square means 10 to the power minus 12 whole square. So that is 24. This is 38, 36. 4 into particles are this. Yes, this is 144 into 10 to the power 9 into 10 to the power 24 into 10 to the power minus 38. So from here it is 144, so that definitely this answer would be coming. So solve this one. Yes, Rishit, correct. So the force is equal to K Q1 Q2 upon R square, and we also write 1 upon 4 pi epsilon and Q1 Q2 upon R square. So here you can see that the force is inversely proportional to permittivity or the dielectric constant of the medium and also with the distance. So both should decrease. So less apart and dielectric constant should also decrease. Yes, option B. Yes, same as the previous question. Same as the previous question. This is decrease because when you put the glass slab, that means you are increasing the dielectric constant. And when you are increasing the dielectric constant, its value will decrease. Force value will decrease. Okay, now answer this. Yes, Manish. Hello. How are you? And कैसे चल रही है आपकी preparation for GATE? And which branch you are from? Which branch you are from? हाँ ये charge है. Charge located at. A charge is located at origin. सो बॉम्बे आंसर आ चुका है। एक चार्ज है दैट इज लोकेटेड एट ओरिजिन, दिस इज सपोज एक्स, दिस इज सपोज वाई। ए पे इलेक्ट्रिक फील्ड, ठीक है, ए पे इलेक्ट्रिक फील्ड जो कि पॉजिटिव है यहाँ पे, और एक यहाँ पे, और एक यहाँ पे, ऐसा दिया हुआ है आपको। बॉम्बे आ गया, ठीक है। तो ये देखो इलेक्ट्रिक फील्ड ए पे, ये ए पे जो इलेक्ट्रिक फील्ड है उसका जो डायरेक्शन है वो है E1 एट द पॉइंट -ए, मतलब ये वाला पॉइंट, ये वाला मान लेते हैं -a और a। यहाँ पे जो इलेक्ट्रिक फील्ड है वो है E2, ठीक है। -a और -a मतलब ये मान लेते हैं -a एंड -a, तो यहाँ पे आपका इलेक्ट्रिक फील्ड है E3, ठीक है। अब आप देखो, ये एमएसक्यू क्वेश्चन था एक्चुअली, एमएसक्यू था क्या, नहीं एमएसक्यू नहीं था। अब दो चीज इसमें एक्चुअली सही हो रही है, देखो इन दोनों के बीच में 90 डिग्री का एंगल बनेगा, बिकॉज ये -ए है और ये ए है, तो इन दोनों के बीच का एंगल 90 डिग्री होगा, तो डॉट प्रोडक्ट जीरो होगा, तो डॉट प्रोडक्ट भी जीरो होगा। और E1 और E3 के बीच में 180 डिग्री का एंगल बन रहा है, तो ये क्रॉस प्रोडक्ट भी जीरो होगा। इसका आंसर क्या होगा, ऑप्शन सी। द राइट आंसर वुड बी ऑप्शन सी, correct. If you make the diagram, because of the charge placed at origin, the charge placed at origin, electric field will be in this direction, and this is in this direction, and another will be in this direction. So E1 and E3 are 180 degree apart, so the cross product is zero. E1 and E2 are 90 degree apart, so the dot product is zero. Okay. Okay, okay, diagram नहीं दिख रहा होगा, let me show you the diagram. Yes, answer this question. देखो अगर यहाँ से ये पॉजिटिव चार्ज है, इसकी वजह से इलेक्ट्रिक फील्ड निकालेंगे, इस तरफ आएगा, तो मान लो इसको E1। यहाँ से ये जो चार्ज है इसकी वजह से इलेक्ट्रिक फील्ड निकालेंगे, तो ये इस तरफ आएगा, मान लो इसको E2। आपको इन दोनों के बीच का एंगल निकालना है, तो ये रिजल्टेंट होगा, यहाँ से रिजल्टेंट इन दोनों के बीच का एंगल क्या होगा, ये थीटा, ठीक है। तो ये आपका E2 अपॉन E1, तो E2 की वैल्यू और E1 की वैल्यू निकालना है आपको, ठीक है। तो E1 की वैल्यू, एक आंसर आ चुका है मेरे पास, तो E1 की वैल्यू कितनी हो जाएगी, ये वाला जो चार्ज है वो 1 माइक्रोकूलम का है, तो Q2 डिवाइडेड बाय आर स्क्वायर, तो यहाँ से आ जाएगा K इंटू 1 माइक्रोकूलम, सो 1 × 10⁻⁻⁶ डिवाइडेड बाय ये जो डिस्टेंस है KQ1 अपॉन आर स्क्वायर, तो हम लोग निकाल रहे हैं 2 के लिए, तो बी की वैल्यू कितनी है, 1, तो 1 आ गया। ठीक है, अब लिखते हैं E2 का वैल्यू। तो E2 का वैल्यू है के क्यू वन डिवाइडेड बाय आर स्क्वायर। सो के इंटू क्यू वन कितना है 2 माइक्रोकूलम, 2 इंटू टेन टू दावर माइनस सिक्स डिवाइडेड बाय आर स्क्वायर, आर कितना है 2, तो ये हो गया 2 का स्क्वायर, है ना। तो 2 का स्क्वायर हो गया तो हम बोलेंगे इसको के, और ये हो गया टेन टू दावर माइनस सिक्स डिवाइडेड बाय 2। अब आप निकाल लो टेन थीटा इज इक्वल टू ई टू अपॉन ई वन ना। टेन थीटा ये ई टू है और ये ई वन है, तो ई टू अपॉन ई वन। सो ई टू कितना है के इंटू टेन टू दावर माइनस सिक्स डिवाइडेड बाई टू, और ई वन कितना है के इंटू वन इंटू टेन पावर माइनस, मैं ठीक लिख रहा हूँ ना, क्यू वन 2 माइक्रोकूलम था, 1 सेंटीमीटर पे प्लेस्ड है, मैं डिस्टेंस ले लिया क्या, ए की वैल्यू जब मैं इसके लिए निकाला क्यू वन के लिए, अच्छा क्यू वन के लिए निकाला था तो मैंने डिस्टेंस वन ले लिया था। ओके ये टू है, ये टू है, ये वन है, थोड़ा सा डिस्टेंस गड़बड़ हो गया। ये वाला डिस्टेंस देखो, वन के लिए निकालोगे तो ये डिस्टेंस मेजर करेंगे ना, ए होगा वो, वन के लिए ए होगा तो ए का स्क्वायर मतलब टू का स्क्वायर, तो यहाँ पे आ जाएगा फोर। ठीक है, तो यहाँ पे आ गया फोर और यहाँ पे आ जाएगा वन। तो k इंटू टू इंटू टेन पावर माइनस सिक्स डिवाइडेड बाई वन, ई टू कितना है k इंटू टू इंटू टेन टू दावर माइनस सिक्स डिवाइडेड बाई k इंटू टेन टू दावर माइनस सिक्स डिवाइडेड बाई फोर। तो ये पूरा कैंसिल हो गया, फिर गड़बड़ हो गया क्या, वेट अ सेकेंड गाइस, आई थिंक मैंने लिखने में कुछ गलती कर दिया है। एक सेकेंड ना, कुछ लिखने में मुझसे गलती हो गई है। टू पॉइंट चार्जेस Q1 2 माइक्रोकूलम का है, 1 सेंटीमीटर पे दूर पे है, ओरिजिन से दूर पे है। ठीक है, तो इसका जब मैं डिस्टेंस लिखा तो 2 माइक्रोकूलम का टू स्क्वायर, यस यहाँ पे गलती हो गया। E1 इज इक्वल टू के, क्यू क्यू की वैल्यू यहाँ पे 2 माइक्रोकूलम है, तो 2 इंटू टेन पावर माइनस सिक्स डिवाइडेड बाय डिस्टेंस भी आपका 2 है, तो 2 का स्क्वायर यहाँ से आ जाएगा के इंटू टेन टू दावर माइनस सिक्स डिवाइडेड बाई टू। ठीक है, अब E2 की वैल्यू लिख लो k इंटू वन इंटू टेन टू दावर माइनस सिक्स, और इसके लिए Q2 के लिए लिखोगे तो डिस्टेंस b लिखोगे, b की वैल्यू वन है, तो यहाँ से आ जाएगा वन। ठीक है, अब हमारे पास जो वैल्यू थी वो हमको कैलकुलेट करना था E2 अपॉन E1, क्योंकि टेन थीटा कैलकुलेट करना है, तो टेन थीटा इज E2 अपॉन E1। E2 है k इंटू टेन टू दावर माइनस सिक्स, और E1 है आपका k इंटू टेन टू दावर माइनस सिक्स डिवाइडेड बाय टू, तो यहाँ से आ जाएगा टेन थीटा इक्वल टू टू, तो ये हमारा आंसर होगा बी। आंसर होगा बी, यस। ठीक है, चलो इसका कैलकुलेट करो। कितना है surface charge density? So because of the surface charge density the electric field is given by rho s upon 2 epsilon naught an cap, where an is the unit normal vector. This is the formula. So this is 20 into 10 to the power minus 9 divided by 2 into 10 to the power minus 9 divided by 36 pi, ये हो गया एप्सिलॉन नॉट का वैल्यू। अब ये नॉर्मल का डायरेक्शन क्या लेंगे, नॉर्मल का डायरेक्शन होता है, द डायरेक्शन ऑफ द नॉर्मल इज फ्रॉम द चार्ज शीट, फ्रॉम चार्ज शीट टू पॉइंट ऑफ इंटरेस्ट। ठीक है, पॉइंट ऑफ इंटरेस्ट, नॉर्मल डायरेक्शन ना, मैं वो नहीं लिखा हूँ, नॉर्मल डायरेक्शन में मतलब परपेंडिकुलर डायरेक्शन पे। सो z इज इक्वल टू 10 पे है, हमको निकालना कहाँ, ओरिजिन पे निकालना है, तो 10 से जीरो पे जा रहे हो, z इज इक्वल टू 10 से z इज इक्वल टू जीरो, मतलब निगेटिव डायरेक्शन में जा रहे हो, मतलब ये कितना आ जाएगा माइनस है। सो ये कितना आ रहा है हमारे पास 360 एंड माइनस 360 पाई and minus z. Option D. Yes, option D. Okay. So thank you guys for watching this session, and this is it from my side. And if you also want to join me for more questions, so we will meet tomorrow. Okay, tomorrow at the same time. Tomorrow at 4 p.m. Every day I will come in this channel at 4 p.m. only. So here we will solve more questions of EMFT. Okay, the more questions of EMFT we will solve at 4 p.m. and we have three session series right now. Then I will bring more series. Like in the previous month also, I have brought some series regarding the signals and the EMFT. So here also I am going to take three session on EMFT in this week. Then next week again I will take three sessions on any other subject. Then again I will take three sessions. In this way, every week I will be taking three sessions of EMFT or signals and system, right? So thank you for watching this, and don't forget to download the BYJU'S Exam Prep app. And if you are interested in the GATE crash course for either you are from EE or EC, you can call in this number and take the detail and join me in the Telegram group that is Study with Saket Verma. And thank you for watching this, and set the reminder every day at 4 p.m. I am going to come in this channel to practice for you. I will bring you some questions and you can practice the questions in 1 hour. Okay. Thank you.